Okay, so what do we do with something like this? So if we're trying to, here's the function f of x, and we're trying to take this limit, right? So let's color code this. F of x plus delta x what's that going to look like?
3 over x plus h.
Right? Minus
3 over x.
f of x is 3 over x, all divided by h as h goes to 0. Okay, so what's a little weird about this is that what's the variable of the limit here? H, not x. Right? The x's aren't changing. The only thing that's changing are the h's. The h's are what are going to 0, right? So what am I going to do? What kind of a technique are we going to use here?
Complex fraction.
Right? Everybody see that? I got fractions and a whole mess of fractions over fractions. So we simplify the top into one big fraction, simplify the bottom, flip and multiply, right? So what's that mean here? What's my common denominator going to be?
X squared plus hx.
No, we don't want to write it that way though.
X
Oh,
plus
x.
h.
X times x, the quantity x plus h, right? We don't want to mix those up. We want to leave them in factored form. That's important. So we've got 3x over x times x plus h. Everybody agree? Minus, and this one I got to multiply by x plus h over x plus h. Right? Does that all make sense? Pause there. So all I did was I just multiplied this one through to get a common denominator by x over x. Right? Okay, and then I'm really just simplifying the top here, aren't I? So the top is all going to become I'm going to get the common denominator of x times x plus h. And now, what do I get? 3x minus 3 times the quantity x plus h. So if I distribute a negative 3, isn't that just going to be 3x minus 3x minus 3h? Right? So all the purple stuff just becomes that. Everybody agree? Okay. And then on the bottom, I've just got my h, or my h over 1. So those guys cancel, right? So I just end up with the limit of negative 3h over x times x plus h. And when I divide by h over 1, I'm just going to flip and multiply. And so finally, I can cancel the stuff that's making it indeterminate, right? Cancel the h's. And that leaves me with the limit of negative 3 over x times x plus h as h goes to 0. And now in the limit that h goes to 0, what do I get?
X squared.
What am I left with for my final answer?
3 over x squared.
There you go. Okay? Makes sense. It's weird that you get variables in your answer, but that's okay, right? We should expect that because the only part that when we evaluate this limit eventually, the only thing we're going to replace is the h. Any other variable in there is just going to stay. right? Okay. What else? So trig limits, okay? So that'll be, there's an assignment on Moodle about trig limits, right? So that'd be a good one to hit. So that's that's most of it right there. That's probably the hardest part, is the stuff up through 1.3. Okay. What are 1.4 and 1.5? One-sided limits, right? So that's going to be the stuff on, if I give you a graph, right? If I give you a graph, could you tell me, easy, right? What's the one-sided limit? Let's build an example. So like, what if I did something like, this is f of x. See the answer. Positive infinity, right? Okay. Okay. That make sense?
Is that like going down?
Well, we're getting there.
Yeah.
Yeah. Right? So that's, and then these wouldn't have to be infinite either. They could be, what if it was a step function? So like, what if we had instead, call this g of x, and g of x does this. Let's say that's down at -2 and +2, so it goes. Right, we could do that. Right, what would the limit of g of x as x approaches 3 from the left be? -2. Limit of g of x as x approaches 3 from the right. +2, okay. Then you got the stuff where, yes, sir?
Can we do a trig one?
Sure. Yeah, we can do a trig one. And so here's kind of what I'll throw out for you, just in general. So today I want to do, the only really thing I want to do to tie up yesterday is I want to maybe take a second look at the intermediate value theorem, and just maybe look at an example of a question like that, which would be good for the review also. But tomorrow, just know this is coming. Tomorrow I'll have a day where I'm at your disposal. So you want to work through anything, work through the homework, anything you got questions on. Tomorrow, bring lots of questions and we can just do examples in class. Okay, make sense? Okay, so let's throw in a trig.
There's one that had like sine squared x.
Okay, okay, so let's, how about like, okay. I'm gonna do a couple of these. So you had sine squared x on the bottom and x on the top, maybe?
Yeah.
Okay, let's try that one. Okay. Was it a one-sided limit or two?
I think it was the whole one.
Okay. Okay. All right, this is kind of a weird one. Was it an x on the top or an x cubed or something?
Which was x.
Okay. All right, this is kind of an awkward one, but we'll do it. I mean, we can answer it. It's just a little weird. Thank you. Oh. There's some spelling there. Okay, so what can we do with this guy? What are the two, what you gotta always start the trig ones with is our special limits, because everything comes down to finding those, right? Finding those. The only way to resolve the indeterminacy, we can't cancel stuff, typically. I mean, if you do, it's kind of that's an easy trig one. But usually, the only way to get rid of the 0 over 0 nature is our two special limits. limit of what?
Sine x over x.
I'm gonna call it theta, sine theta over theta. As theta approaches 0 is 1, and limit of
1 minus cosine
theta, as theta approaches 0 is
theta.
0. There you go. So those are the two that we always have to fall back on. So we're looking for ways that we can break this into factors, and we can break this up into individual limits where these are gonna pop out, okay?
Do you have Chromebooks at the door? String or
Who you borrowing from? Who you borrowing for?
kids down to the office?
Oh, okay, so I think for those, these are kind of tied down. Just go to the ones Mrs. Umbarger's got in the regular car. You can grab one of those. Yeah. Make sure you let her know what you're doing. Yeah. So how could we break this up? What's sine squared x the same as? That's shorthand. Good, so that's the quantity sine x squared, so it's sine x times sine x, right?
Oh, okay.
Does that make sense? Maybe that was the issue.
Yeah, I forgot all of it.
Ah, okay, good. So that's the same thing. When we see sine squared x, that's our shorthand trig for that. Okay, so then we could break this up into the limit of what? What do I do with that sine squared x on the bottom? Right? Does that make sense? And I'll group one of those sine x's with the x on the top. That one we know, right? If we're taking the limit as x goes to 0, what's that one?
1.
Okay, it's backwards, but would you agree that if the limit of sine theta over theta goes to 1, the reciprocal of 1 is just 1, right? Okay, so we don't even have to flip that, right? We can just leave it like that and it's fine. So that goes to 1. What are we left over with, though?
1 over sine x.
Okay, everybody agree? Okay, so when I'm asking these things, I'm going to ask people to raise their hands on these. Because sometimes I want to give people a chance to think about this. From now on, if I'm asking a question, I want to see hands. Yes? No, that's all right, but you can still.
Wait, I just say, then plug in 0, right?
Yeah, so we evaluate it. Okay, but what's the problem with that? Now, if I plug in 0 here, what do we get? Okay, so then what kind of limit would this be? DNE, doesn't exist, right? Okay. But we didn't know that at first, because if I try to evaluate this directly, I get 0 over 0 to start with, which is indeterminate, right? Okay, I'm going to throw a little harder one at you while we're on the subject. How about if we do limit Well, this is getting harder, I guess. So what can we do with this one? What do you think? Yes, sir.
You multiply by 2 over 2.
Sure. Multiply by 1 in the form of 2 over 2, right? And how come? Because because we've got to get it into, it's trying to be this, isn't it? But what's the theta going to have to be? What's it going to be? Well, 2x, right? So theta is going to be replaced by 2x. I don't have the choice of saying, let's let the theta be x and change the sine 2x. That's harder to do, right? I'm stuck with whatever's stuck inside the trig function. It's more difficult to manipulate that than it is to just multiply something on the bottom by 2, right? Everybody agree? So this is my theta. So I've got to create something of that form. So I need the same thing on the bottom that I have on top. Well, to get that, I got to multiply by 2, but I got to multiply both top and bottom by 2. Okay, good. And then if x goes to 0, 2x goes to 0, right? So we can freely change that. And so we just end up with limit of 2 times sine 2x over 2x as 2x goes to 0. What could I do with that constant, by the way? I know this is, yeah, pull it out front, right? That'd be better to do, would be just to pull that out in front of the limit. Okay? So let me just make that little change. And then this whole limit just goes to 1 and we get 2. Correct?
Yep.
Okay, so this is one, not to beat a dead horse here, but this is all good math. It's all good to kind of kick these brain cells free and shake the rust off. We could actually do this one just as easily. In this case, if you remember your trig identities, oops. What is that identity, sine 2x? Sine 2x. So I think we need to have a little, not right away, because we got these tests coming up, but after that, that will be a good opportunity for a free, and you guys should, seriously, this is, it sounds like I'm giving you more work, but I'm giving you a tremendous, doing here, real solid here. I'm going to give you a chance to do a memorization quiz, which will count as a test grade. And all it means is just memorizing some trig identities and proving to me that you have them. And you're going to get credit for a calculus test for doing that. So what do you say? Thank you, Mr. Lloyd. Yeah, that's a pretty good opportunity,
It's
right?
been like 3 months without any trig and like a lot of clues and.
Right, exactly.
I would have
And
known in May.
And so you know that I'm not a big memorization guy, but there's some, when you get to this level, there's some value in having a working knowledge, because it kills your train of thought if you get to something and you say, I don't remember that trig idea. But if you just know it, then you can focus on the calculus and not have to interrupt your train of thought with trying to scramble to find the trig idea, right? So there's not be a ton of them, just the ones that are really useful, and there aren't very many, right? So I'll give you a list, like on Friday, I'll give you, whatever, you guys pick the test date, I don't care. We'll just throw it out there so you get a little time to memorize it, make some flashcards, make a Quizlet, Lily will probably make a Quizlet for everybody.
Did they get shut down?
Did they?
Yeah.
What?
People open the actual test answering on it. It's a lot of shut down.
Okay, AP World History is shaking.
Uh-oh.
I feel bad for them.
Yeah. Well, we are the class that made it, so Mr. Kelm changed all this.
So what is the sine 2x? Does anybody remember?
No,
Sine X, cosine X.
There you go.
obviously.
And look what we got. There's a sine x over an x, right? And so we can, this is easy to do, right? We can just pull that 2 out front times the limit of sine x over x times cosine x. I'm just showing you, this is another quick and easy way to do this. That goes to 1. What's the cosine of 0?
1.
So 2 times 1 times 1 is 2, right?
Can you continue what we were doing?
Oh, well, 2 times 1 is 2.
Okay, thank you. I don't know.
Either way,
Did you see that?
okay? Okay,
This is just.
Just your X. So, I don't,
okay, maybe I'll do one more.
I know what it is.
Oops. right? So it's easy, right? The point being, it's really not a hard problem, but the point I want to emphasize is just that if you have a limit of a sum or a difference, I just break it into separate limits, right? So it's no big deal, right? I just make this into the limit of 2 sine x over x minus the limit of 3x over x. I don't even really, I could just put brackets around it and not even write it as separate limits if I want to. And so here I get sine x over x goes to 1, so I get 2, right? Minus the x's cancel, 3, negative 1. Right? Okay, no biggie. Just want to just a little shake the rust off a little bit. So we got trig limits. That's probably the hardest part, honestly, of the whole thing, is what we've already done. The rest of it, I would say, is kind of all downhill from there. So then if we had some one-sided limits where, like, what if I gave you something like this? What if we did limit of I'm going to make a hard one here. So x squared Okay, so pause, just take a look at that. So what am I doing with this? Okay, a one-sided limit. I'm approaching some rational function as, or I'm taking a limit of a rational function as x approaches negative 3 from the right. Okay. So if I plug this in, I'm going to get, if I did my math right, I think I did, I'm going to get some number divided by 0, right? Which means it blows up. But because I've given you a one-sided limit, this is not a DNE answer. That's not adequate. Right? You want to be more specific with this. Okay. So if we had done this, like if we had done this 2.5 weeks ago, and I had just given it to you like that, the correct answer would have been no limit. DNE, right? Would have been a Moodle 1, and DNE would have been what you enter. Okay? What am I going to do differently this time?
I would want directional separation.
Okay, but to know,
What's happening there?
okay, what's happening there? Now, how do I figure that out, right? This is the stuff, remember, just to jog your memory, we had some stuff where like we'd get an infinity because there's a 0 on the bottom, right? If I try to evaluate this, because I'm getting a number divided by 0, I know right away that I'm getting infinity, but the question is just, what flavor of infinity, right? So let's talk about that. Is it going to be positive or negative? Now, how are we going to tell? And I want you to raise hands. I want you to think about this. It's hard to do. If I try to just plug in a negative 3 plus, so think negative 3.001 or something, right? It's really difficult for me to go through the whole exercise of figuring out when I'm adding up a bunch of terms on the bottom, is that going to give me a 0 plus or a 0 minus? Agreed?
Yeah.
That's a lot of thinking. It could be done, but don't if you can avoid it. Instead, what we'd rather do is get this in factored form, because then we can just apply our simple sign rules to see if the overall product is going to be positive or negative, right? So we take this whole thing, and we're just going to factor the top and factor the bottom. So on the top, what does that factor into?
X minus 2, X plus 2.
Okay, on the bottom.
X minus 5, X plus 3.
Okay. So we know we're getting 0 on the bottom, number on the top, right? Okay. And in fact, let's not even have to think about that in advance. Let's just see what we get when we evaluate this directly. So on the top, as x approaches negative 3, what's that going to be? What's that gonna be?
1.
Okay, on the bottom, what's that gonna be? What's that gonna be?
Positive 0, 0. 0, negative.
So here are the
It's
different
slightly
things.
above
Maisie, what do you think?
negative. So we're gonna take, yeah, so it's gonna be 0 positive.
Okay, so if I'm approaching, I said it wrong before, didn't I? If I'm approaching -3, I did, I said 3 I was wrong. If I'm approaching -3 from the right, what would that be like? 2.999 something, right? So I got something slightly less than -3, slightly greater than -3, plus -3. It's gonna give me a little bit of positive left over, isn't it? -2.999 plus 3 is positive 0.000, right? So I'm gonna get a 0 plus there.
Negative infinity.
Okay, so then what's that give me? Well, I know the 0 on the bottom is telling me infinity. Now we just gotta count the signs. So I've got a total of 4 factors, an even
One's
number
supposed
or
to be
negative, yeah.
Yeah.
One's supposed to be negative.
Oh, you're right.
Oh, good, I thought I was doing that
Okay, no. The universe still works the way it did at the start of the period. It's -1. So now if you count the number of factors that are negative, there's an odd number. So what's that mean?
Negative.
Negative. Okay. I'm just kind of hitting the broad strokes here. You can ask me more specific questions tomorrow, but that would hit the one-sided limit stuff. That hits the infinite limit stuff, right? Man, what else is there? Oh, I know, continuity. So that's kind of the really, we did all this to get to continuity. So that would be the 1.4 assignments, right? 1.4, like it would be, see, 1.4 practice 1, we did some continuity stuff, and then 1.4 practice 2 is the intermediate value theorem stuff, right? Okay. So let's just want to pull up an example of a continuity problem. So, how about, okay, so let's try, okay, find discontinuities. That's what we're doing. Okay, so until I tell you different, that's all we're doing. What about this? What if we have okay, so we see a hand. Something. For f of x. What do you think, f of x? Somebody I haven't heard from. Be brave here.
Yes.
What do you think?
I don't know.
Okay, so let's, before we jump into the question, let's kind of make sure we're just digesting the concept here. So what's a discontinuity, right? Someplace where I'm picking my pen off the board. Okay, where would discontinuities, if I give you a graph of one, it's pretty easy, right? Any place I pick my pen off, you tell me, is it discontinuous? If we wanted to break the discontinuities into removable and non-removable, remind me the difference. Removable means 1 point, just move 1 point, move or define 1 point, and I fix it, and that's stuff. That's the universal.
You didn't do it very good.
Describes the theory.
That's like just one.
So, non-removable would be something that's severe. where I've got to actually change the input number of points and, bring the function together where there's a gap I've got to jump, or an asymptote, or something crazy like that, right? Okay, so where do those occur? If I'm just given a function, where would discontinuities occur? Yeah, dividing by zero, right? Would be an example. If I had a piecewise function, it could be at the boundary between the pieces. That's it though, right? So the question you got to ask yourself is, are there any red flags here? Is there any place where this function, yeah, cosine's fine, right? Cosine's okay. So I can plug in any value of x I want, and I'm just going to get cosine of some number of pi, right? Fine. So the answer, none. It's fine, it's continuous everywhere.
So we're going to get a tangent of cosine power calculus.
Right, so what if we change that? Okay, let's take that. What if we had something like instead, what if we made this tangent of pi x over 2? Okay, now you'd have to ask yourself, where is tangent discontinuous? What I always do, I never remember what the tangent graph exactly looks like. I always think of it in terms of sine and cosine. So tangent is what? Sine over cosine. Okay, so we get so that's all I care about. Where are the zeros of cosine, right? So on the unit circle, where is cosine equal to 0? Raise hands. Let's get hands here. Help me out. What do you think? Jill, what do you got? Okay, good. Cosine's x coordinate, right? So it's going to be on the unit circle, it's going to be there and there. Pi halves, 3 halves pi, negative pi halves, negative 3 halves pi. So odd multiples of pi halves. Agreed? So any place where x is an odd number. So it could be 1, 3, 5, 7. How do we say that, by the way? Let's see hands. Let me get an idea how I can say, how could I list the set of all odd multiples of, how do we do that? Because I don't want to write, it's a long list, right? Where is this discontinuous? This one would be discontinuous, so x cannot equal negative 3 halves pi, negative 1/2 pi, 1/2 pi forever. You could maybe say something like, we'll call it j pi, where I could say j is an odd multiple, or is an odd integer.
This is the x not equal to integration pi over 2.
But really, all x could be 4, right? It could be 6, right? Because if like x were 6, I'd get 6 halves is 3 pi. 3 pi is fine. 3 pi would just be right there, right? That's fine. Cosine's not 0 there. It's only the odd multiples of pi halves. How do I say an odd number? Think about the number sets that we have. This is a good question. Okay, this is obviously a good question. Did you guys not talk about this last year?
We did.
You did talk about like how to say odd.
No.
No.
Okay, so we need to fill, there's a little gap. We got to fill in this gap. So there's a reason for this. Think about the subsets of the set of real numbers. We got the set of real numbers. We can break that down into rational and irrational. What are the convenient ones? Integers, whole numbers, etc. Right? We don't have a typical subset that says just the odd multiples or just the odd integers or the even integers, right? But we could say something like n is an element of the set of, so n is an integer. N is an element of the set of integers. So if we define n that way, how could I say the set of odd integers? How do you get an odd number? Odd integer. Sure. Right? How do you get an even integer?
Power of 2.
No.
Odd plus.
No. Multiple. Right? If I double any integer, doesn't it end up being even? Double and even, it's even. Double and odd, it's even, right? So I could say all odd integers are described by 2n plus 1 or 2n minus 1, probably we do. Okay, either one. Right? So then we could say up here, if we wanted to list the set of all the possible discontinuities, we could say 2n minus 1 times pi halves, or 2n plus 1, take your pick, doesn't matter. Where n is an integer. I'm not going to give you one like that on the test this time. Does that make sense, though? Okay. So there's lots of them for that guy. What about this guy? Yes, sir. How'd you get that? Okay, you could factor the bottom, or you could just say, okay, aha, I see a red flag there. Everything in the red bubble can't equal 0. So if x squared minus 1 can't equal 0, x squared can't equal 1, square root both sides, x can't equal 1 or negative 1. Take your pick. Either way, those are the answers, right?
If it were x squared plus 1, then there'd be plenty of that's it. There'd be no discontinuity.
Then it'd be fine. If it was x squared plus 1, there are no real zeros of x squared plus 1. Anybody see that? So then it'd be fine. Okay? All right? Okay. Another one. We're still finding discontinuities. How are we doing so far? Is this kind of shaking things loose a little bit? How much time we got? 4 minutes? All right, we're good. So we'll do the IBT stuff tomorrow. That's fine, we'll finish that up tomorrow. We're on a roll here. So let's look at, what do you think?
Approaching 2 from each side.
Okay, let's talk about this. So this is a piecewise function, right? So what about negative 2x by itself? Fine. Everybody agree? It's a polynomial, so it's continuous everywhere. Polynomial, so it's continuous everywhere, right? So each one of those pieces is fine, but where's the danger zone? The boundary, right? Either they're going to join up and match, or they're not going to match, and that's going to make all the difference. If they join up at the same point, then it's continuous, right? But if there's a gap, it's discontinuous. How would we know? See hands? What do you think? How am I going to know? How do I know what value the function's going to be approaching when we inch towards 2 from the smaller values? What do we do? Yes, sir.
One-sided limits?
Yeah, one-sided limits, right? So we could take the limit of f of x as x approaches 2 from the left, and the limit of f of x as x approaches 2 from the right. As we approach 2 from the left, we're up here, aren't we? Right? So that's just going to be negative 2 times 2 is negative 4. Right? If we approach 2 from the right, that's going to be, if I plug 2 in here, I'm going to get 2 squared minus 4 times 2 plus 1, which is what? Negative 3? So those don't match up. So what's the answer? Where is this discontinuous? At 2. What kind of discontinuity is it? Removable or non-removable? Non-removable. Okay. The book doesn't talk about this, but answer me this. What's the only way? Now, I'll ask you tomorrow.
How do you tell if it's removable?
That's what I was just going to bring up. Okay, so we can answer it. Well, we'll do it tomorrow. Hold that thought, though. That's, Gabe, that's your assignment. You got to remember to ask that question at the start of class tomorrow.